Let's practice graphing a sine function together. While this particular video is focused on more of the basics of graphing the parent function for the sine wave, feel free to look around my page for some other videos where we graph some transformations of them as well. And real quick, if you want to download a free copy of this PDF, you can find a link in the description box below, where you can also find the annotated answer key as well. Alright, let's get started. We're going to go ahead and graph the function that we're given here. We're going to make sure that we include all of the relative extrema and intercepts, so that's just the highest and the lowest, as well as where it crosses the x and y axis. We're also going to graph as many periods of this function that we can fit on the grid that is going to be below, and we're also going to make sure that we talk about all the attributes of the function as well. So talking about reflections, as well as the amplitude, the midline, as well as all the other parts of this that will make it unique. Alright, so here is our function. We have f of x is equal to sine of x. This right here is the parent function of the sine wave, and all the other sine graphs that you may do are going to be based off of this one. Later on, the sine waves do get more complicated, so keep in mind that we really want to know that f of x is equal to a times sine of the quantity of b times the quantity of x minus c plus d. So the values of a, b, c, and d would cause some different types of transformations, but what would the values of them be if they don't cause any transformations? Because this is, after all, the parent function, so there aren't going to be any transformations. For the parent function, the value of a is equal to 1, the value of b is equal to 1, the value of c is equal to 0, and the value of d is equal to 0 as well. Hopefully this makes sense, because the identity property of multiplication states that you can multiply anything by 1 and it'll stay the same, and the identity property of addition means that you can add 0 to anything and the value will also stay the same. So the values of a and b are 1 in the parent function, and the values of c and d are 0. So for the parent function, we can just write in that a is 1, b is 1, c is 0, and d is 0. Now, the parent function is not going to have a vertical reflection or a flip across the x-axis, because that would only happen when the value of a is negative. So in this particular case, we can say that there is going to be no vertical reflection. On that same idea, if you're wondering if there's going to be a horizontal reflection or a flip of the graph across the y-axis, that is going to be dictated by the value of b. If b is negative, you're going to have a reflection across the y-axis, or a horizontal reflection, but again, this is the parent function, so we're going to have no horizontal reflection. Now, what about the amplitude of this function? Well, amplitude is being dictated by whatever the value of a is. Remember that the value of a could be positive or negative. If it was negative, there'd be a vertical reflection. If it's positive, there's no vertical reflection. So to get the amplitude, what we do is we take the absolute value of whatever a is, and so we just make it positive, so the absolute value of 1 is just positive 1. Next, we have the period, which lets us know how long it takes for this whole function to start and end, and then repeat its cycle. The formula to find out the period of a sine function is 2 pi divided by whatever the value of b is. So for the parent function, notice here how b is equal to 1. So to figure out the period of the parent function, we're going to have 2 pi divided by 1, and that's just equal to 2 pi. So that's how long it's going to take for one whole cycle for this sine function to repeat itself. Now, for the sake of graphing, this can be a little confusing unless you're writing your units in terms of pi along the x-axis. So if you remember that pi is roughly 3.14, then 2 pi must be roughly 6.28. So if you're graphing and you're looking on the x-axis, you would graph about 6.28 as the full cycle here. Next, we have the midline of a function, which is going to be telling us where exactly halfway of the function is in terms of the highest point and lowest point of the function. The value of d is going to tell us if we are shifting this function up or down. So if d is equal to 0, then we're not going to shift at all, so our midline is going to be y equals 0. If we had a positive number, then the midline is going to shift upwards, and if d was negative, we're going to shift that midline downwards. Now, what about the minimum y value and the maximum y value? To find the minimum value, you're going to take the value of the midline, so y is equal to 0, and then you're going to subtract the amplitude. So we're going to have 0 and we're going to take away 1. So 0 minus 1, and that is going to equal negative 1. That would be the smallest y value. As for the max y value, you're going to take that midline again, y equals 0, and then you're going to go ahead and add the amplitude. So 0 plus 1 is going to be positive 1. So while we did talk about the values of a and b and d, we're kind of skipped over this value of c just because we are not dealing with any phase shifts for this particular function. So save that thought for a future video, but if you have a positive value for c, that means we are going to be moving to the right, and if we have a negative value for c, we're going to be moving to the left. To figure out when the parent function is going to start and end, as well as when it is a quarter of the way through the cycle, halfway through the cycle, and 3/4 of the way through the cycle, we have to take a closer look at the period of this function. So the period is 2 pi here. So keep in mind that sine functions are always going to start at 0 for the parent function. And we know the period is 2 pi, so it's going to end at 2 pi because that's how long it takes to start and end. So halfway through, well, half of 2 pi is going to be 1 pi. So that's right in the middle, halfway through. If this is 0 pi's and this is 1 whole pi, then halfway between those two should be half of a pi. So I'm going to put pi over 2 here. And then same thing in between this full pi and 2 pi. Well, halfway between 1 whole pi and 2 whole pi's is going to be 1.5. But I'm going to go ahead and use an improper fraction and write 3 pi over 2. That's just 1.5 pi. And again, if this is a little bit confusing and you're trying to look at this on a number line and everything is just going by normal numbers here, this would be 0, this would be 6.28 roughly, right? It's an approximation. Pi would be 3.14, so on the x-axis you'd be at about 3.14. So then halfway between 0 and 3.14 would be about 1.57 for this pi over 2, or half a pi. And then halfway between 3.14 and 6.28 would be roughly about 4.71. Now we have a general idea of the path this function is going to take. It's going to go through these 5 points, and these are all x values. So we can go ahead and fill in a table here. This would be 0. This would be pi over 2, or 90 degrees. This would be pi, or 180 degrees. This would be 3 pi over 2, or 270 degrees. And this would be 2 pi, which is 360 degrees, which is 1 full cycle for this sine function. Now that we have our x coordinates for this function to graph, let's go ahead and figure out if we can find out our f of x values or our y values. All right, so first we have x is equal to 0, so let's go ahead and see if we can find f of 0. Now f of 0 is just going to be sine of 0. Now for this, you can go ahead and look at a unit circle, or if you have your trig ratios memorized, that's also good, or check out a reference sheet, or you can put this into a calculator. Just make sure you're in the right mode for degrees and radians, but you can go ahead and do that on your own or pause the video to do that. But sine of 0 is going to equal 0, just because I know the y value is going to be 0, so this f of x value is going to be 0. Next, we have x is equal to pi over 2, so let's find this f of pi over 2. If we go ahead and do that, that's basically saying we're going to find sine of pi over 2. Now pi over 2 is 90 degrees, so if you want to do that in a calculator in degrees mode, that's fine. Or if you know that this is going to be a y value of 1, then this is going to be 1. So then you can go ahead and say that this f of x value is going to be 1. So if you look at the unit circle, it should be at the top at 0, 1, right at 90 degrees. All right, let me just move down to get a little bit more space here. Next, we're going to say that x is going to be pi. So let's go ahead and figure out if x is pi, what's the f of x going to be? So let's find f of pi. So let's go ahead and plug that in. That's going to be sine of pi. Now this is going to be 180 degrees, or over on the negative x-axis. And so y is going to be 0 at that location. So we're going to have 0. So when x is equal to pi, then f of x is going to equal 0. If you want to go ahead and plug that into a calculator, you can find in radians mode, you can type in sine of pi, or in degrees mode, find sine of 180 degrees. Or if you look at a unit circle, or your trig ratios, again, that would be over on the negative x-axis where y is equal to 0. Now we have x is equal to 3 pi over 2, so let's go ahead and plug that into our functions. We can have f of this 3 pi over 2. Now this is going to be sine of 3 pi over 2. Go ahead and plug that in. Now this is 270 degrees, or it's going to be the negative part of the y-axis. And if you take a look at that on a unit circle, or again, plug this into a calculator in degrees or in radians mode, you're going to find out that this y value is going to be at -1. Finally, where this period is going to end is going to be at 2 pi. So we're going to have f of 2 pi. So let's plug in 2 pi into this sine function. So if we find sine of 2 pi, then 2 pi is 360 degrees, or that's back to where we started. So that should be back to 0, because it's going to be the same location as f of 0, right? Those are going to be coterminal angles, and so we know this is going to be back at 0. All right, so we have a table now, so let's see if we can go ahead and put this on a graph. Let's go ahead and take our x values that we have over here and put them along our x-axis, so feel free to scale it as you need to. Here I wrote my 5 important x values that are going to represent one period of this function. So basically I'm going by half a pi here for each of these tick marks, but that's also basically saying I'm jumping by 90 degrees. Here you can see I filled in a few more to the right of our period. And here I filled in a few more x coordinates to the left. Now in terms of our f of x values, that's going to be same as our y, so y is the same thing as f of x here, right? Now looking at the range of our y values, notice that our highest value is 1 and our lowest value is -1, so we don't have to go too far. So here we can label it as 1 and this we can label it as -1, but feel free to scale it differently if you'd like to use more or less of the graph. So these first coordinates of the parent function are going to be 0, 0, so I'm going to go ahead and plot that down right at the origin. The second point we're going to have here is going to be pi over 2, 1. So let's go ahead and plot that down. It's going to be pi over 2, or 90 degrees to the right, and then up 1. For this third point, we're going to have pi, 0, so that's going to be 180 degrees, 0, or we're going to go over to the right pi and then stay along the positive x-axis. For this third point, we have 3 pi over 2 for the x coordinate and -1 for the y coordinate. So let's go to the right 3 pi over 2, and let's go down 1. So that's over in quadrant 4 here. And for this fifth point, we have an x value of 2 pi, and our y value is 0. So let's go ahead and plot that. Let's go over to the right 2 pi, and then stay along that positive x-axis to the right. Trying our very best to connect these dots to make a smooth curve here. This would be one period of our sine function. Now remember, the directions did say to fit as many cycles or periods as we could along here, so just continue this pattern then in all of these spots to the right. Just continue that wave, go up and then in the middle, and then down and back to the middle, and then same thing to the left side. If we continue this curve, let's move down, then back up, then above the x-axis, back to the x-axis, below, back to the x-axis, above, and then back down. There's a rough sketch of our graph continuing to the right, and there's a continuation of our sine function to the left. Now let's see if we can label a couple more pieces so you can put all this together. So remember our midline from earlier, we said our midline was this y is equal to 0. So if we go ahead and take a look at this, let me show you where that is. Here is that horizontal line of y is equal to 0, so that's our midline. It is right in the middle of our sine function. And then what else can I kind of show you a little bit more clearly here, hopefully? Well, we can also see maybe our minimum y value, which was -1, and our maximum y value, which was +1. Maybe we can go ahead and show that as well. What color did I use? I used that other color here, so let's go ahead and show that. Here we can see that our maximum y value is up here at y equals +1. And our minimum y value is over here at y equals -1. And then taking a look at our a value of 1, we can see that our amplitude is 1, so from the midline, we do move up 1 to our highest y value, and we also do move down 1 to the lowest y value that we have here. So the amplitude hopefully makes sense. The absolute value of +1 and -1 is just equal to 1, so that's why a is equal to 1. Let me see if there's anything else maybe that's worth mentioning here. I don't really think so. I think everything's kind of taken care of. And hopefully you found this video pretty helpful in sketching this out. Once you know the parent function really well, this should really hopefully help you have a stronger foundation in graphing all your other transformations. So I think this is a good starting point if you're just trying to wrap your head around graphing sine waves or sine functions. Everything else is going to stem from here. So try to just remember that sine waves always are going to come up and then down, and then back up as its first wave. Everything is going to be basically copying and pasting this, and then maybe moving it up or down, left and right, maybe stretching it and reflecting it and things like that. But you got to know these original points first. So this table over here is a very good one to kind of memorize or just get to know really, really well, because everything is going to be replicated from here. So hopefully you found this video helpful. If you did, please consider giving it a thumbs up and sharing it with a friend that might find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.